Hello everyone, my name is George Jimenez and I'm taking historical geology. This is my regional report, which is going to be on Montana, and here what I have representing Montana is St. Mary Lake in Glacier National Park, and the state's state animal, the grizzly bear. Alright, first let's go into the Archean basement. Is the oldest material, would have to be quartzite and also schist. It goes back to at least 4 billion years. Right here the photo, this is Beartooth Highway in Yellowstone, which has granitic gneiss. That was part of the old Wyoming Craton when it was called Laurentia or the American Plate. So I thought that was pretty cool. This is pretty Devonian in age. Here's some cool stuff in the next slide. Oh, just stuff of the granitic gneiss. Here I have a photo of my own personal sample of granite, and here's from the roadside geology of Montana. A nice picture of some very nice. The gneiss contains small hornblende fragments as well as bits of flaky mica in it. So you know it's very shiny when you look at it up close with the hand lens, or even when it glistens from the sun when you look at it in just the right way. Let's see what we got next. I'll touch on this in just a little bit, but let me go back a slide actually to just go over the our usual or crusty old sourdough makes perfect toast, juice, and coffee. I'll save the toast, juice, and coffee for when it reaches to the Mesozoic era. But for right now, I'm going to go over the Cambrian, just to get that out of the way. The Cambrian can be found in the Judith mountain range in Montana, which contains mostly clay, silt, and sand, and quartz. And then towards the Cretaceous, these sand rocks were made into domes, and then these domes were then broken by faults. It's pretty crazy. They were uplifted, whoa, way up. So they were pushed up. The next one we have, well, forgot to say, Cambrian is 541 million years old. Next we have the Ordovician, which is just more sedimentary rocks, but aren't too commonly found in Montana, so not really much to write home about that one. But the Ordovician is 485 million years of age. Next is the Silurian, but yeah, same with the Ordovician. There's not too much of it in Montana, but the Silurian was in 443.4 million years ago. The Devonian, which is a lot more prevalent than the others, but that's the one, as I said, found in Beartooth Highway. All these little formations right here, Devonian in age, really cool. And the Devonian was made in shallow water with there was a lot of marine carbonates at the time, and there was a lot of more sedimentary rocks. Next we have the Carboniferous. Which, as the Devonian, just a lot more sedimentary rocks. But these rocks are divided into 4 pretty big groups. One is called the Madison, another one is called the Big Snowy, third one is called the Amsden, and the last one is called the Quadric Formations. And the Carboniferous is quite well exposed, well, on the flanks of tertiary uplifts. So that's pretty amazing to see. And to wrap this little portion up, we end it with the Permian. And the Permian here in Montana has primarily phosphorites, sedimentary rocks, and phosphate minerals. And these were formed in deep water wedges next to the continental shelf. Alright, and then we go to here. The diabase dikes and sills. Here's another photo from the Roadside Geology of Montana. This is a great book. Totally highly recommend for all my geologists. So the belt formations have plentiful amounts of dikes and sills that are made up of diabase basalt. Seeing these tell us that there was definitely a continental rift. We can use the diabase to tell us when the continent split, which was roughly 500 million years ago. So that's pretty amazing because of the basalt eruptions that would happen. So that's what you see coming up right there. The dike and the sill going in between the contacts of the rock. And here we have the Precambrian belt formations. You can see it all goes along right there. Pretty cool. Due to the fact that it's Precambrian in age means that the fossils found in the belt group are roughly 600 million years old and only contain certain plants and algae. So, you know, we're looking at our stromatolites, one of our very first organisms. And this is also in the Roadside of Geology. And I just love the way it has its pictures laid out. Now, what is the Montana Belt Group? The Belt Pucelle Supergroup in northern Idaho, western Montana, is a thick succession of Mesoproterozoic sedimentary rocks with an age range of about 1470 to 1400 million years. The belt group is composed of the lower belt, the Ravalli group, the Piegan group, and the upper belt. And here I have this little diagram from a very cool article that I found that kind of shows you exactly where the groups are in Montana. Here we have the Missoula group, which is a part of the upper belt. So we have Missoula going right here, Piegan going along right here and here. And what's the basement rocks right here? But this photo is more better than that other photo, in my opinion. In this photo, it shows what each part of the belt group is made out of and the respective formations. Put it right here. I really like this diagram because you know where everything is alongside its composition. So that is very cool. I'll go ahead and go through it with everyone here. So here we've got the Missoula group, which is part of the upper belt. Give me 1 second, please. The Missoula group, the Piegan group, the Ravalli group, and the lower belt. So here we have the formations from west to east. So Libby Garnett Range for the Missoula. And we see it goes. And this one, since it's dark green, it's made of hummocky, cross-stratified quartzite and siltite. Yeah, a lot of Montana is sedimentary rocks. Just a lot of it being uplifted and pushed all in the front. Here we have the Piegan group with the formations of Wallace and Helena. Here we go. Light blue, all right here, the dolomite and argillitic carbonates. And here for the Ravalli, we got Grinnell and Spokane Formation and Upper Burke and Rivet. We have mud cracked argillite and and it looks to see that we have, I believe, flat laminated quartzite, argillitic quartzite. And for the lower belt, we have the Picard, which is what I go mostly in here. The Picard is what is made up of the turbidite sequence. Where do we? Picard right here. And it goes down right there with the brown and orange. The orange is the quartzite. There we go. The quartzite turbidite, and the dark brown is the fine grain turbidite. So that the turbidites are composed of like the regression and transregression of the coursing and finding upward sequence of the minerals collected in those, like the rock we did in that said lab. And also too, like it's mafic sills right here. Very cool to see. I love this thing. This is my favorite one of the whole presentation. Now to go a little more in depth of the groups, the lower belt. The lower belt is the most basal strata of the supergroup. It is incredibly thick, as thick as 12 kilometers, which is pretty thick. The Picard Formation is 6 kilometers thick and filled with coarse grained turbidite deposits. As next one, the Ravalli group. Now we went from the newest to oldest. Now we're going from oldest to the newest. Now next is the Ravalli group. Ooh. Oh, I forgot to say that the Picard have outcrops of priotite iron sulfates, and most of them are red due to how they oxidize. So I think that's pretty cool. But for the Ravalli group, it is as you can see right there, above the lower belt, but contains purple and green argillite marks and fine grained clay. The formations that are involved with the Ravalli are the Burke, Spokane, Grinnell Formation. And what the sediment tells us how the change from the lower belt to the Ravalli, and how the Ravalli was made from the shallowy water. We're getting more of our sediments there. Next we have the Pegan group, which was also called the Middle Belt Carbonate. Here we're gonna find an abundance of dolomite and calcite, which also contains oscillated ripples, which tells us that deposition was in deeper water than compared to the Ravalli. So here it's a little more shallower, but as we go to the Pegan group, it's like a lot more to the wave action as it oscillates. It's a lot more defined than the Ravalli. And next is the Missoula group. And here most of the formations in the Missoula group are quite sandy and contain siltite, argillite, which is also similar to the Ravalli. And the belt C shallowed and had regressions and transgressions, which give us alternating fluvial and shallow water deposits. So I just like the way this gives us our cool water ripples. Next. Alluvial sapphires. Here's what it's creating today. So I'm going to read word for word just so I can not butcher this in any way I can. The surfaces of some of these sapphires, as revealed by the removal of kaolinic coating, are almost completely covered by conchoidal fractures. Internal conchoidal fractures are also coated with a very thin layer of kaolinite. We interpret these features to indicate that these sapphires were brought to the surface by violent volcanic eruption, and the accompanying of volcanic ash was weathered into kaolinite. The most recent rock that we see is yielding sapphires, and that is important because, as stated above, the sapphires are only produced through volcano action. So, the sapphires are brought to the surface by igneous rocks that are high in aluminum, but low in silicon like basalt. So I thought it was pretty cool. Put in a little sapphire ring there. I think the next slide has a bit more of a realistic what you'll actually pick up in Montana. Here's one of the this photo is pretty funny. Here's one of the mines that they go down into, and for the sapphire, and this photo is intertwined with a link that is to a shop purely for sapphire rings for women. It's quite funny because this is the photo associated with it. But here is a more what you'll find and how it's gonna look without it being all shined and cut and buffed. This is like the most raw material you'll find, which is, in my opinion, the more impressive to me. So let me go ahead and read this quote off to you. While the Hugo Gulch is Montana's only primary sapphire deposit, alluvial deposits occur near Phillipsburg, Rock Creek, Deer Lodge, Dry Cottonwood Creek, and Helena. El Dorado Bar is the largest and most known for its approximately 14-mile-long Missouri River deposits. This side's kind of funny. Before I get into some dinosaur goodness, we need to remember that before the Mesozoic, there was a constant movement between the lithospheric plates, which created a large conglomerate of continental crust, which gave us a huge supercontinent. But as we all know, there is one thing called Wilson cycles. So this is a supercontinent that will be destined to come apart. How sad. And here I have a little photo of continental drift. I'm breaking up with you. It's so straight. Like the puzzle piece. But our supercontinent here is going to be Pangaea, and that's what we're going to be working with. But the Mesozoic is composed of your toast, juice, and coffee. The Triassic, Jurassic, and Cretaceous. The Mesozoic! Hooray! Who knew this was going to be my favorite part? It wasn't very much of a surprise. The Mesozoic. During this time period, most of the Montana was quite close to the sea level, and because of how the shorelines kept on shifting, it caused the continental crust to rise and sink, which led to the flooding of about 2/3 of the state. But the most fascinating thing about the Mesozoic to me has got to be the dinosaurs! That's my favorite part. Who knew? Who knew? Here I've got this is the state of Montana's state dinosaur, which is the Maiasaura, which I'll go into a little in depth as I go along. So let me go on. Well, first let me just talk a little bit about the Triassic. The Triassic. Most of what you'll find here is dolomitic, mudstone, siltstone, and shale. So our usual shale, said rocks, and limestone. It is deposited in shallow marine environments. There wasn't much dinosaur action going on in the Triassic. There was cool stuff, but not technical dinosaurs. Only conifers, cycads, and ginkgos. There's some ginkgos today, but I forget where exactly. All right, let's go to the most famous formation in Montana, the Hell Creek Formation. Let's put a little fire there for a little pizzazz. The Hell Creek Formation was a meandering stream that existed during the Cretaceous, and the dinosaurs that would die next to the meandering stream would be covered by the sediments, and then millions of years later would turn into the fossils we see today. Most important rule about being a fossil is that you need to die. You gotta die first. That's number uno. In some specific way so that your bones won't get eroded or weathered away. The most famous fossils you find here would be that of the Tyrannosaurus Rex and Triceratops, which I have a little photo right here. T-Rex and Triceratops. I even have a little book right here that I want to show you guys. Okay, let's go to T-Rex. Here we have our T-Rex. Very cool. Sharp teeth, little claws. You know the deal. I even had this uber cool model that I wanted to pass around class, but I got sick. Unfortunate, I know. This would have been very cool to share with you guys, but what are you gonna do? Alrighty, let's go to the next one. I'll save that slide. But now that we're done with the Tyrannosaurus and Triceratops, these are going to be found in the Cretaceous, but I'm not in the Cretaceous yet. We're going to get right there. Right now we're going to go into the Jurassic, which contains another quite famous formation, which is the Morrison Formation, which is also one of the best spots for fossils in North America. This one's composed of, again, more sedimentary rocks and granite. Here you find some pretty cool and humongous dinosaurs. These are called sauropods in the Sauropodomorpha. Like Camptosaurus, Apatosaur, and Diplodocus. And I will show you what those kind of look like. Here's a Diplodocus, which was pretty big, roughly around 82 feet or 25 meters long, tail to head. So this was a big dude. I don't know if you could see, but that's a person for scale with one of these things. Oh man, you know, I'm gonna be stepped by this. Okay, T-Rex, Diplodocus, Jurassic. And now the Cretaceous. Even more sedimentary rocks, if you could believe me or not, which contain shale, mudstone, siltstone, sandstone, and igneous rocks. And you can see the Cretaceous dinosaurs are represented here by the Tyrannosaurus rex and Triceratops. Alrighty, now the Maiasaura, and why I dedicated a whole slide to it. The reason that I put the Maiasaura in this last slide is because of how it is the Montana state dinosaur, and for good reason. Another formation that holds significance to it would be the Two Medicine Formation, which also goes by Egg Mountain. I wonder why. Because of how they had found a nesting ground for the duck-billed Maiasaura. This showed the public that dinosaurs were not just ruthless killing machines, but had a soft and tenderness within them. They weren't these drooling monsters to fear, but they're also loving parents, like we will eventually be. Here is an example of Maiasaura, the duckbill. And here more eggs. Here's the scale with a person. So it was quite large. It was 30 feet or about 9 meters long. I also forgot to show you guys the skeleton of Triceratops. Yeah, this thing's a bruiser. You can see this one compared right here to a human. Pretty big, pretty big. The main takeaway that I want you guys to walk away with about Montana is that it is covered in a multitude of sedimentary rocks that were uplifted by faults, and also contains a rich history of fossils. The next slide. Thank you so much.